You may wonder, where does this superclass subclasses coming from? Or how can you create a superclass or subclasses? And this will comes to our next bulletin item, specialization and generalization. So for the first one, specialization, basically I can tell you this is a top-down approach based on something that you already have, and then you try to create subclasses based on that one. So specialization is a process of defining a set of subclasses of an entity type. Just like the employee, based on the job properties, then you can subcategory of the secretary, engineer, and technician. The set of subclasses based upon some distinguishing characteristics of the entities in the superclass. It may have several specializations of the same superclass. Just like we see, based on how they get paid, we can subcategory of the salary employee and hourly employee. The subset symbol on each line connecting a subclass using the fork symbol indicating the direction of the superclass and subclass. The open end of the fork symbol indicating that is going to be the superclass, and the other direction specifies the subclass. So we have seen these figures many times. You should have a very good understandings about this one already. At the same time, if we want to map this concept into our project, which is about IMDb, I'm going to give you an example such as the awards. You may already have the award entities in your database design already. And try to understand this. Project number 1 is about an ER diagram. So everything that we discussed in the EER diagram part should not appear in your project 1. So think about this. If you have an award, based on where the award is developed or awarded, we can subcategory the award into US award as well as the global award. US award indicating those awards comes from United States, such as Oscar. Global awards can be Golden Global and many other things that in Asia, in Europe, that provides the awards. So you can see that based on that, you can subcategory into 2 subclasses already. And there's many possibilities that you can come up with in the real world example. So suppose specialization, which is a top-down approach, attributes of a subset are called specific or local attributes. I use the word local attributes since the beginning of this chapter. The subclasses can also participate in specific relationships types. So that means the subclasses can have their own local attributes as well as their local relationships. There are 2 major reasons for including class-subclass relationship and specialization in a data model. So the first one, certain attributes may only apply to some but not all entities of the superclass, just like the secretary. They have the typing speed and others don't need that, as well as the technician grade does not apply to the secretary nor the engineer. Some relationships are maybe only participate in the subclass only, just like the manager to the manager. And that's why, to make it more accurate, we would rely on the EER part for us to specify those details. In summary, the specialization process allows us to do the following things. We can define a set of subclass of an entity type. We can establish local attributes as well as the local relationships that we feel only this one applicable. On the other end, this is what we call the bottom-up approach. Generalization is the reverse direction of the specialization. Several classes with common features are generalized into a superclass. So when that is happening, if you try to merge 2 or 3 different things into a superclass, then original classes become subclasses. Let's take a look at an example. Cars, vehicles. So saying that we are a dealer and we have two entities. One is cars, the other one is about a truck. So Toyota has their own models of the cars as well as the trucks. So you're developing those two entities in the beginning. And while time involved, you may notice that there's actually quite a few attributes that are common to these two entities. So it is normal process that merge those common attributes into a superclass, while car keeps its own distinguished attributes and truck do the same thing. So let's take a look at this one. Say now originally the cars is developed as the entity with 5 attributes. Well, truck has another 5 attributes. And now while we try to look into it, both of them has price. They also have the vehicle ID and as well as the license plate number. So by seeing that, it is a possible process to merge those those 3 attributes into a superclass. And of course, we can give a different name, say called vehicle. And in the vehicle, we can have the vehicle ID, price, license plate number, etc. And then we can have those subclasses with their own local attributes. So you can see originally car and truck are entity, and now they became subclasses. So this is giving you an idea of what the generalization can do. If I'm going to use similar things back to the project, in the project, you may already have several entities regarding to the people. So you can have an entity of actor. You can have an entity about director. You have another entity about the writers. And you may notice that there are many attributes that are share the similarities. So it is totally possible to create a superclass based on those 3 subclasses. And the superclass can call, say, celebrities, which is probably what IMDb has been used, because they do have the some information regarding to what we call celebrities. In this case, that celebrity become the superclass, and actor, director, and writers become subclasses. So those are the things regarding to how can we generate superclass and subclasses. The next video will want to talk about the constraints regarding to what we say the single line, double line, which represent the same idea of the total and partial in the relationships, as well as 2 choices regarding to the disjoint or overlapping.